Hi, my name is Ritashi Sengupta and I'm doing my Masters in Biomedical Engineering in SRM College, Chennai. And this video is a part of my Masters course, so I'll be explaining my Masters project in this video. It is a year-long project, but I will try my best to explain it as briefly as possible. The title of my project is 3D Modeling and Analysis of Customized Dentures with Magnetic Implants. Firstly, let me tell you what are the main objectives of my project. There are four objectives. Firstly, to design the 3D model of the denture and to design and to perform the 3D model of the magnetic implants. Next, the implant and the denture needs to be assembled. The third is to apply the biting force on the assembled model. And fourthly, to perform an finite element analysis on the designed model and to analyze what are the force bearing capabilities of the model. Now, to coming to the basics, what is a denture? A denture can be loosely known as a false tooth, or it is usually a replacement of natural teeth. When is it needed? It is needed when the natural teeth are lost due to certain reasons. For example, maybe natural loss of teeth or accidental loss of teeth or rotting away of teeth due to tobacco use or drug uses, etc. Next, these dentures, when they are placed in the jaws, they need to be kept in place by something. This something is usually an implant, and an implant can be of two types, mainly two types. They are the magnetic implant and the mechanical implant. The mechanical implants are the most common ones. They are mainly the bar and the ball, the clip or the ball and ball type, and they are more commonly used in today's world. But the magnetic implants are the ones which I have used in my project. They are not so common and mainly still under research, but in certain part of the world, like certain parts of Japan and a little bit part of UK, they are a bit in use, but not very popular yet because it is, like I said, still in research. Now, these magnetic implants are usually of two different types, that is the open circuit type or the open field type and the closed field type. Now, if I need to explain this, I need to go to the basics of the magnetic implant design. Now, going to the basics, the magnetic implant design can have only two parts, two main parts. The first part is the attachment, and the second part is the keeper. The attachment is the one which remains in the denture, the modeled denture, and the keeper is the one which is surgically implanted into the alveolar bone or the gum if the gum is present in the patient, depending upon the patient and depending upon the case in which how the patient has lost the teeth. Okay. Now next is why are they called closed circuit or the closed field ones, and why are they called the open field ones? Now this the attachment which I said, the attachment has two parts. The first part is the permanent magnet. The permanent magnet is the main component of the magnetic implants. This permanent magnet always remains covered with something, some material. Now, depending upon the material, they are either called the closed type or the open type. If the material which covers the permanent magnet is a soft magnetic material, it is known as the closed field magnetic implant. And if it is covered with a non-magnetic material, then it is known as an open field magnetic implant. The keeper is always made up of a soft magnetic material. Now, the retentive force in the magnetic implant depends upon the force of the permanent magnet and the keeper. The keeper, like I said, remains in the alveolar region, and the attachment remains in the designed abutment or the designed tooth or the gum or whatever it is designed according to the cases. Now, the second thing is, now I'll go to the materials that I've used. I have collected patient specific data, that is, I've collected CT images of patients who require this denture replacements, And then I have converted this CT images into DICOM format, and I have utilized three softwares. First is the Mimics, which is from the Materialize, and the second one is SolidWorks. It is basically a modeling type of a software where you can model very easily with measurements and everything. And the third one which I've used is ANSYS, and that is what I used for finite element analysis. That is all the analysis that I've done regarding the force bearing capability of the models that I've designed. Now going to the methodology. I have first taken the CT images, and then I have converted it into DICOM format, which is an acceptable format in Mimics software. In Mimics, I have first done the thresholding and the segmentation of the required region and then smoothing, and then I have calculated the 3D model of the required region. From the 3D model, I have taken the dimensions. I have measured the dimensions of the teeth and the required dimensions that I need to model the 3D denture, the 3D modeling of the denture. Next, with the help of these dimensions, I have modeled the 3D model of this denture, patient-specific denture in SolidWorks. It is very easy to use SolidWorks, that's why. Then I have taken designs of the implants, magnetic implants, and I have also performed the 3D modeling of the implants in SolidWorks itself. The third step which I did is I combined the designed model of the denture and the designed implant together, and next I have meshed the whole model. This meshing I have done so as to reduce the stress points of the model. Reducing the stress point is very important, because if the stress points are more, when I'm doing the finite element analysis, the maximum stress of the model will increase to a very high level, and that will not probably be accepted as clinically accepted models. So I've done the meshing and the smoothing of the models so as to reduce the stress points. Then I have applied the biting forces. On the biting forces, firstly, what I did is when I took the complete denture model of the upper jaw and the lower jaw, I applied the average biting force, which is 353 Newton. When I did that, I realized that the stress point is coming quite high at the molar regions. And in that case, what I did is I applied 3 implants. I incorporated 3 implants in the model denture, which I did. And I placed the implants at the 2 molar teeth at the 2 sides and one at the incisor position. So the molar positions had a very high stress points. So next what I did, I took out the molar position, the incisor position and the canine position of the tooth, and I did the whole process separately for all the 3 different regions, and I have analyzed the results again. So for the molar tooth, again, this time I did not apply the average force, that is 353 Newton, whereas I applied the maximum force a molar tooth can bear, which is 747 Newton. And in case of incisor, I have applied 149 Newton, and in case of canine tooth, I have applied 484 Newton. So after applying all these forces in the direction of like for the teeth of the lower jaw, I have applied a negative direction force, and the teeth of the upper jaw, I have applied a positive direction force. And then I have done a finite element analysis so as to realize which are the maximum stress points that are coming, and whether the maximum stress or the maximum displacement of the model when these forces are applied, whether it is fine or not. I've realized that the maximum displacement is quite less, and it is in the acceptable regions, and the maximum stress also comes within the acceptable region. So I realized that when I am doing the individual tooth, I have done a little bit more of smoothing, a little bit more of meshing and reducing the stress points, due to which the stress dramatically comes down from a 4-digit number to a single-digit number. This is very practical, because when we go to a doctor and we do this, we go for a denture replacement, and the denture that we are using, or we are buying and using to replace our teeth, they are usually go through a lot of smoothing and lot of thing. So when I'm doing it in software, it is quite acceptable thing. So from this study, that I can come to this conclusion, that the model that I have the 3D model that I have constructed from the patient, and the designs that I've taken, both the closed circuit and the open circuit ones, and incorporated them into the model, and putting in the biting forces and doing the finite element analysis, this whole procedure and the result that I've got, it is quite acceptable to the normal cases when we are doing in a normal lifestyle. The what I can say about my study is, it reduces a lot of time, because if we go for a normal denture replacements, it will minimum take a month, or maybe 4 sittings or 5 sittings with the doctor, and only then we can get it. But this, in this case, the since the implant that I'm using, which is the magnetic implant, it is very small in size, but the retention force is pretty high than the mechanical ones, and these are very comfortable to replace if a need comes. For all these reasons, the magnetic implant is obviously very good, and using the magnetic implants and the softwares to design, and the method that I have followed, it can be used normally. But the future work of my project is that this model needs to go through the clinical phases, the clinical study phases, and only then it can come to market. Thank you.